Hi, welcome. In this particular module, we are going to study how to make the decisions. You must have gone through the welcome video, so we know the context of what we are learning. Now, in this particular module, we are going to study about the if, switch, and conditional expression, if and switch statements, conditional expressions. We will do some nested if statements as well if we need that, and also we will see that given a C++ code for a particular program that uses any of the language element presented in these particular discussions. Now let's move on. Let's see what are the relational operators we are talking about. So what do you mean by relational operators? So in a C++ code, you have any program, you have an identifier. Let's say x is an identifier. It's an integer, let us say, and then x equals 4. You want to see if the value of x equals 4 or not. So in that case, you do this is the identifier for equals. So this is your expression to verify if x equals 4. And whenever you try to validate that, you typically write the syntax of the language is you write if, then you put a parenthesis, you write x equals 4, and then you put a curly brace, and then you end the curly brace and you write some statement here. Let's say you write cout, and then you just write something. Let's say x is 4. I'm This is an example. Okay, always remember that you should put a curly brace, the one we are showing here, this curly brace. Why you need this? If you have a single line of code, you won't need any curly brace, but it's a best practice if to use curly brace all the times, because in case you have multiple lines of code, then if you don't put the curly brace, then only first line followed by the if statement will be considered as a part of the if statement. So do not fall into any error path by not including the curly brace. So that's why make a convention that you put all, I mean, all for all if statements, no matter how many, what is the length of your conditional block, you will do do a set of curly braces. Now, this one is the this one. I'm talking about this one. This is the conditional statement which involves a an identifier, a relational operator, and the target. I mean, this could also be an identifier, but we will talk about it later. But the result of this particular element is a boolean, true or false. So if you say if x equals 4, that means if x equals 4 statement, the relational statement, if it is true, then you do something else, you do something else. Now, this is called inequality. This particular symbol signifies inequality. This is greater than, it's same as your mathematics. This is less than, this is greater than equals, this is less than or equals. So these are mostly useful relational operators. Now you can use a Boolean example just like I used this one. I mean x equals 4. This one you can see we did here as an example counter equals 5, where counter is an identifier. Or you can say test core not equals 0. I mean, this is also another identifier, but it says test code, this identifier is not equals to 0. Or you can say yes greater than 0. So it is a greater than a numeric literal. I less than months. Look, there is some difference. What is on the left hand side? You have I, which is an identifier. What is on the right side of this relational operator? This is months. This is also an identifier or variable. So I can be less than, the left side could be related by a variable, related to a variable as well, rather than a simple numeric literal. But here, next line, subtotal greater than equals 9.99. It says that an identifier subtotal is greater than equals a numeric literal. Next is quantity less than equals recorder amount. This is also here also you can see that less than or equal to a variable. It's not a literal but a variable. So 0, 9.99, these are called the literal, numeric literal, but this is called a numeric variable. Okay, and another condition is that if you want to establish some relationship, some relational operator, the left side of the operator that needs to be as same type as your right side of the operator, meaning you cannot compare a number with a string, you know, you cannot compare a boolean value with a string. Okay, so these are some requirement, because C++ is a strongly typed language. So it is driven by the types of the variables. So that's why it is important that we know that the left side of the relational operator and right side of the relational operator, the both the variables needs to be of same type. Now, how do you test a string or a character for the equality? It's simple. So you write choice. Choice is an identifier of the type character. So char, and then you write choice. So this is a character literal, character identifier, and you simply put equals equals and then you have y. Note that this y has a single quote. Whenever you use a single quote around a single symbol, single character, then this is called a character. But things get different if you have a double quote. Double quote stands for a string. So name is a string, this is a string literal. So name equals equals string literal, some string literal. Or you can say name not equals name2. This name2 is a string variable. So here also you can see that the same set of um, like for the equality purposes, the similarity equality operators could be used for establishing the equality or inequality. But be careful about single quote versus double quote. Always remember, single quote stands for a character, whereas a double quote stands for a string. Next is two functions that convert the case of a character. So when you use two lower and two upper, it means two lower means whatever character you put here, it is automatically going to the lower case, or two upper means it goes to the upper case. So when you say this one, two lower choice equals lowercase y, that means if choice is y or capitalized y, it really doesn't matter, because if your choice, the value of the choice, the user puts it as capitalized y, then it is lowercased, right? It is being lowercased. But if you put small y, then also it is automatically lowercase. And if you apply two lowercase to a lowercase character, it doesn't matter. It remains in the lowercase only. The syntax of the if statement is as follows. You write, as I said before, it is like you write if, then you have the Boolean expression. The Boolean expression means if you write x greater than 5, this is a Boolean expression. If the value of the variable x is greater than 5, then the expression is evaluated to be true. If the value of x is not equals to, I mean, if it is equals 5, it is false. If x is less than 5, that is also false. So you write if the Boolean expression, then you write the statements. Now, if statement with only one if clause, I mean, you can see here double discount percent 0.05. If subtotal less than equals 100, then you write discount percent equals 0.01, 0.1. So it's a 10% discount, let's say. And if statement with an else clause looks like the below. So in a code, you write double discount percent. This is a variable you declare. And then if the subtotal greater than, if you purchase more than $100 worth of materials from a store, then you are getting 10% discount. Otherwise, you are getting 5% discount. So this is the programmed version of this one. Okay. So let's do some example. Let's say the same discount. Let me open up the Visual Studio. So let's create a new project. It's a console application. Next, and we can say um, conditional. The project name is conditional. So I am opening the project. So this project is created. Now what we can do, we can delete all these lines, focus on here. We can do using namespace std, and then we can say float discount equals 0.0505. So this is the default discount, 5%. Let's say we are talking about a store, bookstore. If you buy more than $200 of books, then you are getting 20% discount. So you write if, let's write the price, float price equals 0. I mean, that's the default value. If price greater than 100, you can also do like this, cout enter price. So you are asking user to do something. So now you are doing cin price. So you are getting the user data. So you can say cout user entered price. I mean, whatever value user entered, we just confirmed here. Then if price is greater than 100, let us say we are applying let's say 200, then you are applying a 20% discount. So we can say discount equals 0.2. Okay. Then we can say else if, means if that is not the case, but uh, else if, that is you are doing another condition. If price, the you are purchasing more than, let's say if it is more than $200, you get 0.2. If it is between 100 to 200, so you can say if the price is greater than equals 100 and price is less than 200. So you see here we are putting a compound conditional clause because we are combining two conditions with an and statement. We are going to learn about this and statement. This means, this is and means this one, the price is greater than equals 100. This needs to be valid, it needs to be true, as well as price less than 200, that part needs to be true as well. Then only the whole expression will be evaluated to be true. Okay, so you can write discount equals 0.01, 10% discount you are getting. And for all other cases, what do you mean by all other cases? If your price is less than $100, okay, so then you are getting a discount of, sorry, 0.05%. So basically, you don't need to apply 0.05 here. You just say that you have a discount. This is an identifier, price is an identifier. Now you are asking your user to enter the price. The user enters the price. Let's say the user enters $500. Then what will be the value? What will be the discount? So you are doing C out. The discount is discount. So tell me what will be the value of the discount if the user enters $500. So the value will be what? Value will be greater than 200. So the discount will be zero point 0.2, right? Now, if the user enters $170, where does it lie? It is between 100 and $200. So the discount will be 10%. Let's say user enters $217. What will be the discount? It will be zero point 0.2 because it is still more than 200. So let's test it. Let's run the program, right? So the console appears. So the user is instructed to enter the price. Let us say I'm writing $217. Then you see the discount is zero point 0.2. Okay. So that's the power of the if statement. So you have a logic. Now giving you some parallel comparison. Let's say you are writing an artificial intelligence program. What does it do? An artificial intelligence program, it's a complex, they have a complex logic, they have complex design, they have complex structure, but you know they are also subject to certain conditional validation, like this one. Some if and else if or else statements, they may have. Let's say you want to find some reference, some reference about uh, something, some medical test. Let's say you write uh, that can I can I buy a medical test, given medical test from a given pharmaceutical company or testing service? Can I buy, can I just on demand order a blood test, whatever blood test it is, from, let's say there is a pharmaceutical, I mean, testing company, ABC test, not giving any name. So, so in the AI, in the background, they write some program, doesn't matter in which languages, they will gather the information from the ABC company, and then they will simply run an if or else statement. So they will find the test name and they will look up on the list of the test, and if the test name is not found there, so if the test is not equals that whatever test you require, then they will say no, they will write a C out. Let us say if they were to write in C++, at some point they would do the comparison, and then they will write that it is not available. So whatever you write, I mean, today we are learning this simple logic, but this is the start of our journey to be integrated into a larger picture. So pay attention to your current learning, right? So we learned about the if and else statements, which is kind of great. So you can have a multiple if and if else statement. That's what we did right now. We had two of them, but you can have multiple if and else statement. But here you can see everywhere there is a single conditional expression. But I have shown you there can be a compound conditional expression. We'll get into there soon. Now, if statement without braces that causes an error, you have to be cautious about that. You know, let's say you have a use case if your subtotal is um, greater than $100 and the discount percent you get zero point 0.1 and your shipping method becomes FedEx. Now the question is, now for this code, let's say you include a subtotal of $50. What is your expectation? I mean, if you think the entire block is subject to if statement, then you would say, let's say you put $50, then you won't see FedEx as your shipping method, right? But that's wrong because you don't have any curly brace wrapping up the limits of the if statement. So here you are getting, yes, you are getting a discount percent of 10%, but shipping method is you are getting a 10% if it is greater than equals 100. For $50 purchase, you won't get it. You get only 5% as in the top. But the problem is your shipping method is always said to be FedEx because there is no curly brace produced, I mean, inserted across, wrapping up the conditional, the logic, the statements within the if logic. So your second line, I mean, your third line is automatically executed. So that's why I kept saying that always make it a practice, even it is a single line of statement, wrap every if statement with the curly brace. This is a good coding practice. So this is the way you can fix the error. But you don't have to follow the rule, any rule like if you have more than one statement, then only I am going to add the curly brace. What I'm suggesting you, make it a rule that I'm not using any if statement without the curly braces. That way you will be pretty much immune from this type of uh, confusing errors. And if you are writing a 1000 lines of code, if you are writing, let us say, 100 modules in a package, then it's very easy to miss something if you don't follow such conventions. And then when you encounter the real problem, it may be harder for you to exactly troubleshoot and locate the source of the error. So that's why use that kind of coding convention that whenever I have an if statement, I'm going to use curly braces. So you can see that there can be clauses that contain multiple statements. Like here under this first if statement, you have two, I mean, if block, you have two statements. Under the else block, you also have two statements. So in these cases, your use of curly braces are sort of mandatory. But even if you don't have multiple statements, use the curly braces to avoid any confusion. So this can be another, I mean, this is the first coding style, like after the if condition, you put a curly braces on the same line. Another coding convention is you do it in the separate line. This is good in case you want a better readability of the code. Your code is much more readable in this case. If you think about an enterprise, a team that is creating some programming, they have their own convention, and most of the times they used to adopt this style, the one I'm showing in this slide, over this style for the curly braces, because this style, the other style, this one is much more visible compared to the other. So I'm not going to do that, but here, there is a invoice program. I mean, a closer approach to that we already coded, so I'm not rewriting the program or re-explaining the program, but make sure you go through this program, try to write it on your Visual Studio IDE window and try to run it. So you have now the logical operator. We talked about the double AND symbols. This one, this stands for AND. This symbol, these double lines, they stand for OR, and you already know about it. This stands for NOT. The order of precedence is NOT, and OR. So you can have the Boolean expressions, and then you can have compound logical expression in this way. Let's say age is greater than 65, greater than equals 65, and age and city equals Chicago. So suppose you are trying to find, your program is trying to locate some person whose age is greater than 65 and they live in Chicago, then this will be the logic. This will be the uh, this will be your conditional expression. You can have millions of people with this profile. So, in order to narrow down further, you have to have other criteria as well. But then you see here, not operator, what does it mean? It means not age greater than equal 65. So, what kind of population we are meaning here? It should be age always less than 65, because it's not greater than, it's not equals, it should be less than 65. And two operators, uh, you can have age greater than equals 65, city equals Greenville, and state equals South Carolina. That is even narrowing down your expression choice. Now you can have two OR operators like age greater than equals 65 or age less than equals 18, status equals retired. So can you tell me, here, let's say the city is not Greenville, what is going to happen? This expression will be evaluated to be false, right? But here in this expression, if the age is 55, the first clause is false, but the second clause is valid. So, and the third clause doesn't matter. I mean, one of the clauses, if it is valid, then it will move forward following this block. Okay? So that's the beauty of the, uh, compound operators. Now, and and or operators um, with parentheses to clarify sequence. You can have like greater than equals 65, age greater than equals 65, and status equals retired, and age less than 80 or less than 18. Suppose you are causing some doing some of the policies here, some health policies or whatever, payment policies. Then if you just restrict the conditions within parentheses, then you know that you these two go together and this is standalone. So this is very important to understand. And also you can see here that age is greater than equals 65, and then status equals retired, or state equals South Carolina. So this is a separate type of um, OR operators. So be careful about what you want as a part of, what is the requirement that you are trying to implement in your code, and design your code accordingly. Otherwise, you will face problems when you get the outcomes. So there are a lot of examples here. We also did some examples in our about the compound conditional statements. So we'll be going through that, right? Now, there can be an if statement that validates the range of a score, you know. So score is greater than equals 10 and score is less than equals 100. So then that means your score is within 0 and 100, right? And if statements can validate the customer type. So in this case, the second case here, in this case, this is about like uh, verifying the string, I mean character variable with a character reference. Okay. So the discount rule, a table that summarizes the discount rule is something like this. Let's say you write R, the retail invoice subtotal is less than 100, you don't get any discount. If it is between 100 and 250, within the range of 100 and 250, you are getting 10% discount. More than 250, you are getting 20% discount. For wholesale, if it is less than 500, you are getting 40% discount. If it is more than equals 500, you are getting 50% discount. So um, this is the discount rule. I mean, you summarize. And how about converting it into an if statement? So let's say if you want to do that, um, let's follow this path. So let's bring it here. So let's build it like that, whatever you require. So let's say we are doing here, uh, we are creating the main program for that. Let's get rid of everything from here. Okay. So let's delete everything. Now let's start writing the program. So we can say um, the customer type. So you can say character customer type. Okay. You don't have to reinitialize it. You can say float total. You don't have to initialize it either. Now you can say float discount. You may make it 0. Now you can say ask the user to enter what is the customer type. Okay. And then cin, we write customer type. Okay. Now next we can say cout what is the invoice total, and then we see in the total. Now we have to run the if, I mean logical block. We can say if customer underscore type equals retail R. So what you can do here, you can do to lower to make it universal kind of stuff. Okay, so you make it too lower so that you put capitalized R or small r, it really doesn't matter. You can say now you can start a block. You can say that um, if total is less than 100. So you can say um, Cout, or you can just say uh, discount equals 0. Now you can write else if, total greater than equals 100 and total less than 250, then you can say discount equals zero point 0.1. I'm just following the rule above, right? Good enough. Now, finally, you can say, um, now you can do another else if, or you can just simply say that else. For all other criteria, you can say discount equals zero point 0.4. Okay. So this is your retail customer. Similarly, you can do a cut paste and then modify. Now you can do customer type equals wholesale. You put W. So then your rule is if it is less than 500, you get a 40% discount. You know, for greater than equals 500, so you can say else you are getting a 50% discount. Okay, so that's our code. If we translate the requirement into the code, it looks like this. It's simple. Now we can do Cout. The discount is discount, or you can say here as well, Cout. The customer type is, that's what you entered, cust type, end line, Cout, then you do the total purchase is total. So that's it. That's all of our code, and we can say end line here. Okay. So let's try to execute the program. Here comes the program. So let's say we are doing a retail customer, R or capital R, doesn't matter. So what is the invoice total? Let's say we are putting an invoice total of $20. So then, as expected, the discount is 0. Execute the program again. Let's say we have a um, wholesale customer. Let's put W. And then let's say the discount is, you are having, there is a mistake in the code. I should have written here, what is this? It's not right. I should have written here zero point 0.4. That is your 40%. So let's run it again. So you have a wholesale customer, W, and the invoice total, let us say 499, less than 500, right? So you are getting, you know, 40% discount. Now let's say we have another situation where the customer is retail. So let's write retail R, and then let's say the total is $200.58. Okay, so we expect it to be 10% discount. Let's see. So we are getting 10% discount. So similarly, if you run other criteria, you will get different discounts. So this is the way you could implement this logic into the program. Okay. So we did this. This situation is called nested if statement. You know, we did like if you look at our code, there are if statements, else if statements inside one principal if statement. So this is a situation what you call nested if statement. Okay. So if statement that gets the same results, I mean, that's what we did there. You know, you have um, you could make it compound. I mean, rather than using the nested if statement, you could make the compound if statement as here. So instead of using if customer type equals R, and then you do all this logic, you can do customer type is R and subtotal so and so, customer type is W and total is so and so. So you can do you can blend your logic like that as well. Okay. So there can be a conditional expression, something like that. You know, you can express your conditional expression in that way as well. This is much more readable. This is much more compact statement. So how do you use this one? So such a way of writing expression is called ternary operator. You know, a ternary operator evaluates the test condition and execute an expression out of two based on the result of the condition. So basically you are writing some condition in the first here, and then you evaluate the condition and then you are writing certain expressions. Okay? So this is an example of the ternary operator in C++. So you could do it in this way. Let me, let's say we are we are doing it like this. So if you want to use a ternary operator, you could use it in this way. Total, or not this way, this block. Let's use it in this block itself. So you can say total less than 500, then you put a question mark, then you write the condition when total less than 500 is true. That means your discount becomes zero point 0.4, and then you put a colon, and then you write the condition when total is not less than 500. That means greater than or greater than equals. That means the else part. So you write zero point 0.5, and then you equate this one to discount. So that is it. And you can see that in this way, your code becomes extremely compact, that you are writing uh, and if you are replacing an if and else statement with a single line of ternary operator. So if you want to validate the code right now, let's run the code and let's make a condition so that it goes to the wholesale customer, so W, and then we can say invoice total, let's say it is 650 $670. Okay, so if you do that, then you see that you are getting 50% discount, and this is by using this particular ternary operator. So that's a great tool to make your code real compact, right? The thing is, when you use a ternary operator, then you have if and else, these two logic. I mean, you cannot have an if and else. I mean, multiple if block, you cannot support it using that. So you can use a statement that uses parentheses to identify the Boolean expression. So you can do in this way. It's almost the same as what we did before. Uh, so you can see that's what we did. I mean, I showed you the example similar to this. S- So, so far we have learned about the if statement, and the great thing is that we can use a ternary operator to use that compact if statement. So next we are going to learn about the switch statement in the next video.